All right, so in this lab, we're going to start using different instruments. And of course, different tools are going to have different levels of precision. So for example, you could say that, you're 6 foot tall. If you want to be more precise about it, maybe say, you're 6'1" or 6 foot 1.1 or 6 foot 1.1.1111, something like that, right? The more numbers that you have, the more exact your answer is, the more precise it is. And the reason that we don't just make every instrument have a whole lot of precision is because it's very expensive and difficult to do. Generally, if your instrument or tool has more precision, it's generally going to be more expensive. And so, right, it's important for us to be able to read tools correctly because we're going to be using them throughout the course, and we want to make sure that we're, of course, reading them correctly. And so the way that you use any kind of measurement tool is we're going to report the numbers that are given, right, that we actually see on the instrument. Those are our certain digits. And then you're allowed to estimate one of them. That's your uncertain digit. But both of these count as significant figures, which we'll learn about later on. But we're just going to introduce them for the point of lab. That way we know how to use this correctly, right? So here in this image, we've got this block in the center. And then we've got two rulers, ruler A and ruler B, and we're going to measure how long this block is using these two rulers. So if I look at, this block, there's the height, right? I can line it up to my ruler and I can get my length of my block. So I can tell for sure I'm greater than 4 and less than 5, right? So I know my measurement using ruler A is going to be 4, right? That's my certain digit. But then after that, I don't know exactly where it's at. Is it 4.6, 4.7, 4.8, 4.9? I can't really tell, so I'm allowed to guesstimate, right? So I'll say it's about 4.8. Maybe somebody else would have written something else down. That's totally fine because when we write numbers in measurement or in science, we know that the first set of numbers are our certain digits, and then the last digit is always the uncertain digit. So whenever you see any kind of value reported, you know that the last digit, unless indicated otherwise, is uncertain. They estimated it. Let's go ahead and do the same thing to this block or with ruler B. So again, we know it's greater than 4, but now we know more information, right? This is 4.1, 4.2, 4.3, 4.4, 5, 6, 7, 8, 9, right? So now we know it's greater than 4.8, but not quite at 4.9. So now I've got two certain digits. And again, I'm allowed to estimate one more digit. So it looks like to me it's closer to the 8 than the 9. So I'm going to say 8, 2, right? And so then this 2 is my uncertain digit. So you can see how ruler B is more precise. It gives us a more exact answer than ruler A, right? And if we had an even better ruler, we could become more and more precise until, kind of the point of why do you need to know exactly how long this block is. Note that all of these numbers count as significant figures. So this top one here has 2 sig figs, while this number down here has 3 sig figs. Obviously, the one with more significant figures is going to be the more precise tool. Or instrument. You can use those words essentially interchangeably in this course. All right, so another example, here's a thermometer, right? We can see that here we have 16, here we have 17 degrees Celsius. So I know it's greater than 16, but less than 17. So I can write 16. Those are both my certain digits. I know for sure those two numbers are correct. This next one I'm allowed to guesstimate, right? So I'll say about 16.4. That'll be my uncertain digit. And then again, there I have 3 sig figs, right? There's 3 numbers, the 1, the 6, and the 4. Then we have the thermometer down there. So there's 16, 16.1, 0.2, 0.3, 0.4, 0.5, right? So now I know for certain that it's greater than 16.4, right? Those 3 numbers are my certain digits. And then I'm allowed to estimate one more. It's about halfway through. So I'll guesstimate a 5 there, right? 16.45. And again, the lower tool here is, again, the more precise tool with its 4 significant figures. Just some other notes. We're going to measure some liquids. Liquids will form a meniscus. That's this kind of little curve here, right? You see how it's kind of curving there. It's not totally straight. Liquids will form that. The rule of thumb is to read at the bottom of the meniscus. right? So not the top, but the bottom, right? So again, you want to kind of read down here-ish, right? You can see it pointing down there. And if we read that, we could see, oh, I know for sure it's greater than 21. After that, I don't really know. It's about maybe a little bit over halfway. So I'll say 21.6, right? Those are my certain digits. That's my uncertain digit. And of course, we can include the units if we want. Later on, we'll learn more about units and their importance. All right, the final thing is be careful of which way the numbers go, right? So sometimes, most times, right, as it goes up, the numbers increase, right? So 5, then 10, then 15, right? That's the most common way. But it's not always like that, depending on what instrument you're using and what the purpose of it is. So for something like a burette, it's used to dispense liquids. So as we're dispensing liquids, right, all the liquid's going to be kind of coming out of the bottom here. It's not in this picture. And so the numbers are flipped, right? 3 is up here, 4 is down here, right? So just be careful with that. So let's go ahead and just read this, right? This is 3 up here, this is 4 here, this is 3.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. So I know it's greater than 3.6, and then I'm allowed to guesstimate one. It looks very close to that, so I'm going to say 3.61. Right, so you can see here we have 3 sig figs. Otherwise, it shouldn't be too bad. A little bit of practice, which we're going to get during this lab, and you should be able to read our tools correctly, and that'll give us a good foundation for the rest of lab.